Applications of linear equations, interpreting the meaning of the intercepts. What we're going to be looking at here is a graph and a word problem where we're going to be talking about the intercepts. Quick reminder, the x-intercept is where the y value is 0, the y-intercept is where the x value is 0. And it's really important that we focus here on the units and the scale. What are we measuring? What are we talking about on the x and y axes? Okay, so it says interpret the intercepts of, in problem 1 we're given a graph. The title is Number of Malls in the United States. And by the way, I should say that I made this stuff up, so don't trust me on this, don't quote me. Okay, so the x-axis scale goes by 2's, and it's called years since 1980. So that would mean that this first line is 1982, this one's 1984, 1986, etc. Then on the y-axis we have number of malls, and it's called in thousands. So the number that's marked is 10, that represent 10,000, 15,000, 20,000, etc. Okay, you could always write those little notes to yourself, but it's important to think about these numbers before we dive into the intercepts. The only intercept I have is right here, 0 for my x value, 5,000 for my y value. What does that mean? Well, if I have 0 for my x value, that means 0 years since 1980. I'm going to write in the year 1980 something happened. And in the year 1980, there were, according to our y-axis, 5,000 malls in the U.S., which of course is probably a little bit low. I just made up this information. But that's what an intercept tells us. It tells us the starting point. For this data collection, whoever did this made-up study, they started collecting their data in 1980, and from there they found a couple other values to draw this linear relationship. Let's look at another one. This is one that I think is a little more important. Again, I made this one up, but this is something that naturalists really do. The population of species X is estimated to be 280 in the year 2000, and then estimated to be 200 in 2005. If no interventions are taken, when will the species become extinct? I think this is a really interesting problem because this is something that is pretty realistic. Like, this is something that we really do have to face. Like, when is this population going to run out if we don't do anything about it? It doesn't ask you to make a graph, but if you're a visual learner like me, it might help you to sketch what this looks like visually. So I have number of species. I chose to skip by 100s because my number of species goes up to 280. And then on my horizontal axis, I'm going to call that years since 2000. So that year 0 would be 2000, and then year 5 would be 2005, year 10 would be 2010, 2015, etc. Okay, so let's get those points on there so we can see what it's talking about visually. The population of species X is estimated to be 280 in the year 2000. So I'm going to put a little dot right here at 0 years, 280. When their study first started, there were 280 in the population. Then it's estimated to be 200 in the year 2005. So that's what this is going to look like right there. So graphically, I could draw the line here and look for where my population number reaches 0, and I could do a pretty good estimate based on that. Of course, I'm not using graph papers. That wouldn't be the best method. What I'm going to do instead is use slope-intercept form of my line. Okay, here's what I mean. First, I would calculate the slope by doing y2 minus y1 on top of x2 minus x1, and I get negative 80 over 5, which is negative 16. That tells me, by the way, that my change in y, so change in species, I'm going to call it individuals, I guess, individual species x, is on top of my change in x on top of the years. It tells me I'm losing 16 of these species per year, 16 birds per year, 16, I don't know, they are woolly mammoths, are going away each year. My species population is declining by 16 individuals per year. Now we can use the point slope form of the equation to find out our prediction. Y minus a y value, you can use either one. I'm going to use 0, 280 because those numbers, I always think 0 is a little bit easier to work with. X minus my x value, simplifying. Y minus 280 is equal to negative 16x, and then minus 0. Then to get y all by itself, I would add 280 to both sides. Okay, so let's talk about what that means. Y represents number of species. It's equal to negative 16 times number of years since 2000, and then plus 280, because that's where the population was at the start of my study. Using that, I can find when will it be extinct. That's when my y value is 0. Subtract 280 from both sides. Divide both sides by 16, and I end up getting 17.5. That means the year 2017 is when I can expect my population to be extinct. And that's pretty close to what I got when I graphed it. So you can see that intercepts have a really important role when you're looking at linear relationships represented in graphs or in word problems.